Alright, Introduction to Artificial Intelligence, Mark Toussaint. 10. Dynamic models. Motivation outline. The lecture covers the special with graphic model with the dynamic part with the weight graph with the roughly chain, the trip of the massive of the Markov, the process of the hidden Markov model. When random variable, the dynamic process of the not observable, these model with the cornerstone with the time series with the analysis as well, the temporal model with the language for instance, the special case for the inference of the continuous size, case of Kalman filter, which could be used with the tracking object for the state with the controlled systems. Markov process with the change of the Markov with the trip with the X of the dependent bound set with the ends first with the Markov process, second order Markov process. Sensory Markov is assumption and sensory process transition models and sensory models fixed for all t's. Hidden Markov models would assume that we have observed the discrete with the continuous variables of y t with each of the time slice, discrete latent variable to the x, and each time place some of the observation model of the transit models. Hidden Markov models define a joint distribution and difference inference problem with the Markov model of the marginal posterior filterization. Prediction smoothing and likelihood calculations, vertebral alignment finding sequences, and the maximize parameter for this is done with the maximum product instead of the sum of the product message passing. Intervariance in the HMM tree. Marginal posterior of the product with these three messages, past, now, and future. For all XA condition independent of the XB given the XT with the YA with the independent YG with given the XT, future independent of the past given from the present with the Markov property. Interference HMMs, applying general message passing equations. Interference HMM's implementation notes the message passing equation implemented interpreting the matrix equations, vectors corresponding probability tables of the let be the matrix and techniques, and then when the element of y is private of the product where O is O is an element of y is private of the quantity of the vector entries of the quantity at a time matrix entries and over the equation of the quantity that describes the time and the parameters. Son of a bitch, it gets very complicated. Inference of the HMM classic deviation general of the belief propagation inference of HMM is simple reference here is a more classical derivation. Note at the agent time there is the same as the agent at O at on all other sides. HMM remarks the computation of forward-backward messaging a Markov chain is also forward-back algorithm. Sometimes computing forward-backward message creep with the continuous context of the Bayesian filter smoothing EMG algorithm. HM parameters also go BUM-WEC algorithm and latent variable to continuous the discrete structure of the Markov models called the shaded space model with a continuous transition observation or linear Gaussian. Then forward-backward messages are Gaussian and forward filtering, also called Kalmanian filter, some of the other Kalmanian smoothing. Kalmanian filter example, the filter of the position, and the 2D filtering of the true of the observed and filtered. And then Kalmanian filter example, smoothing in position. HM example learning Bach, listening with a read of the notes of the Bach pieces over and over again, and so both the learning how to write Bach pieces itself, at least harmonizing themselves, harmonizing chronicles and styles of the JS Bach moral, using HMMs or sequences for soprano melody, latent sequences, chord and harmony. HMM learning Bach results. See also worked with Gerhard Widmer. Dynamic Bayesian and networks are attributed to Bayesian networks each time slide special cases of Markov decision processing speech and processing speech and etc. Alright, 11. Artificial intelligence, machine learning, and neural nets. Motivation outline. Neural networks become an essential type of the machine learning AI, but in principle, they just the parameterized functions they can be fit into data. Like many appealing aspects that were focused on the machine learning research in the 90s to the 2010, so why we're successful now. In lecture, the basic tries to discuss the success of neural nets. What is AI? AI is the research field. AI research is about systems that take a decision. AI formalizes decision process, interactive decision, changes the world state or passive. AI distinguishes between agents, external world, and decision variable. The system to take optimal, desirable decisions. AI formalizes a decision objective. AI aims to form systems exhibit a functional desirable behavior. Systems take optimal decision basis of all available information. AI is about inferences, and AI is about learning. What is machine learning? In large part, machine learning is, let's call it the machine learning O. Fitting function X is result gives the resultant Y to given data of set X and Y at the end to the I is equal to 1. What does this have to do with AI? Literally not much. The decision-making machine learning method is only a single decision deciding on the function of the hypothesis space, and single decision process not interactive. Machine learning does formalize a model, consider how to choice the changes of the world. The objective of the machine learning depend only on the given static data, and the decision f for the function might change. The f might change the world. F might change the world. Learning that machine learning not interactive process with the same method of picking f on the basic of the static d, but typically iterative. The optimization process, not decision process, of machine learning focuses on. But function approximation can be used to help solving AI interactive decision process problem, building a train and fix into the interacting system based on a human expert knowledge, and engineers enter the neural net, the frequent function to recognize the sheet signs based on a large fixed data set, and start he builds function into the car driving autonomously. The car suddenly solves the AI problem. The function continuously makes the decision to change the shape of the world. The function was never optimized literally with the task interacting with the world. It was optimized to minimize the loss of static data. It is not prior clearing to minimize the loss of the function of the data related to the maximum rewarding in car driving. The fact that the only expertise of the engineer is not that some of the AI algorithm discovered that the fact that no place there was an AI method of learning to drive a car. There was only optimization method that minimized the loss of the data set. Machine learning interactive decision process approximate with the quantity function, state evaluation function, reward function, system dynamics, etc. Then other artificial methods can use the approximate models of the actually take the decision interactive context. Whereas machine learning beyond machine learning at 0, large points of machine learning is let's call it the machine fitting function of the X is given in the Z data set. Beyond machine 0 ML 0 or 1 for more structured models of the data, which include the time series of the recurrent process of the graphic models, unsupervised learning, semi-supervised learning, but in all cases scenarios still not interactive with the data and static, and the decisions about it picking up a single mode of the function with a hypothesis space for the objective is log based on the function and data only. Active learning, where the machine learning agent makes the decision about the data labeled as query. The next, bandit reinforcement learning, machine learning objective materialistic risk minimization with hypothesis space functions. Standard parameter cases and our functions as describe the parameters, and given the data, the standard objective to minimize the error of the data, where L is Y, uppercase Y, and greater than y, 0, penalize discrepancy of the model output, y, uppercase Y of the data Y, squared error, classification error, non-log likelihood, L, and etc. Was a neural network, a parameterized function. Zeros are called weights, minimum of 0 with the logarithm n to the I to 1 of the L, the F to O times X to I times Y is called training. What does the neural network stand for? For neural net resistance and rheostic layers activation functions applied element Y's rectified linear unit. Legally rectified linear unit, sigmoid logistic tangent H, neural network's basic equation. Consider L the hidden plus output of the historic dimensions, the ZI inputs of all the neuron layers 1, and activation of all the neuron layers of the L, redundantly we denote that by XO is X. 4 propagational layers of the neural net recursively computes, and then computes the output for the inputs of all the neurons in L and all the Backpropagation gives some of the loss with recursively compute loss gradient input layers of the L, whose element of Y is product of the gradient Y's weight rated training weights is behavior gradient propagation. Back through the many of the layers lead. The problem of classical sigmoid is always a vanishing agent. Modern activation functions reductions that reduce this problem. Initialization weights and super important initialization weights, standard deviation roughly 1 over the hysteric of L roughly if each of the element Z and standard deviation results in the same should be true with Z1 plus ZL plus 1, and in regression regularization, standard regression cases, historic L will typically assume the squared area loss of the function L with the logarithm we have. Regularization, old L2 with the L2 or L1 regularization first computes all gradients from before and added with the gradient historically is called the weighted decay, with the additional gradient leads to the top of the decaying of the weights modern dropout. Optimal outweights of the standard regression, and X is the data matrix activations. Neural network classification, multi-classification that we have the historic L, M output neurons, one of each class of the function of the X for the or discrimination function, which means that the predicted class for the argmax, class for the neglog, likelihood objective logistic regression, the hinge of the loss objective with the reversible neuronegative and semi SVM. With the correct class, like the short notation for the discriminated value of the class Y with the 1 versus all hinge loss, output neuron in play with the gradient, output neuron in play with the gradient, only data points instead of the margin induced an error of the gradient. This is called precipitation algorithm. Alright, discussion why neural nets are successful now. Historic perspective. This is completely subjective. Early from the 40s of the McCullough, Pitts, Herbie, and the Rosenbolt. Worms, back propagation, 80s, start connections, NIPS, ML1, machine learning wants to distinguish itself with pure statistical machines and agents. 90s to 2010s, more theory, better ground, statistical learning theory, good machine learning, pure statistics again. Pearsonian Bayes, graphical models, Bayesians, X, some efficiency, greater generalization guarantees, theory, greater success, application across the discipline, supervised, unsupervised, structured. 2010, big data, neural network sizes matters, GPUs, and distribution function on images, software engineer becomes central. Neural network did not become better than they were 20 years ago, but the standards of the 90s to the 10 will still be horrible. What changes standards by which they are evaluated? Old sample efficiency generalization get more little data guarantees both a weighted rate of time rate generalization optimization being only as good with the nearest neighbor method is embarrassing. Newly ability to cope with the billions of samples that result with no batch processing and sophisticated optimization. Happy to end up with some of the local optimum theory on every local optimum over the large deep end is not, and that is good. Stochastic optimization model or atom without monotone convergency. Nobody compares the nearest neighborhood methods. The nearest neighborhood 1B data points to extensive anyway. I want to guess that I'd perform very well. Descent kernel with the neural net could be glad to perform equally well. Neurosnap, the nearest neighbor. Imagine the autonomous car instead of carrying a neural net. It carries 1 petabyte with the data with a 500 hard drive, several billion pictures every split second into the record of the image of the camera wants to query with the database to return 100 most similar pictures. Perhaps the non-trivial similar metric that's not reasonable, but the incentive of the neural network are much better with the nearest neighbor. So we're compressing and huge amounts of data, whether they actually generalize better than a good nearest neighbor method is not so relevant. Those how standards change from the 90 to 100 to nowadays. Image times and time series. I guess 90% of the recent of the neural nets for the area of the image of the time series, the image of the conventional neural nets or CNNs, and POV is very sensible prior to the representation emerging of the convolutional neural networks or facts similar to the representation visual area of the brain. For time series, long short-term memory networks present long-term dependency on a wave of well-trainable, something that is hard to do with the other mental structures. Both structural priors combined with a huge data capacity makes these methods very strong. Convolutional neural networks, standard fully connected layer with a full matrix with a H1 to H1 parameter conventional. Each of the neuron entry that receives the input of the square receptor field over the KK parameter. Neuron shall be parameter of the translucent invariance of the whole layer over the K parameters. They offer multiple neutrons on the same receptive field with the depth over the layer with a representative of the different filter of the string leads with the downsampling padding it or the orders pool applied with a predefined operational receptive field with no parameters, max or average, typically with a downsampling. Learning to read these diagrams. And then pre-trained networks, ImageNet, Net5K, Alex Network, VGG, RestNet, RestNet XT, long short-term memory network. A long short-term memory is a memory signal multiplied with a sigmoid signal that is unsaturated with the memory preserve of the propagation copies of the gradients back. If the saturated is close to 1, the new signal is written into the memory. The saturation is 0, but the close to 1 memory contributed to normal neural activities. A collateral benefits of neural nets. The different computational graphic paradigm, perhaps new paradigm design large-scale systems beyond the software engineering teaches classically. Neural network diagram specification languages models click the network together high expensive with the creative with formulating ruling novel methods auto encodes embedded to control the gains. Optimization, sortation, gradient descent, standard optimization with the gradient descent, backtracking, line searching, LBFGSA, other quasi-new methods with a strong guarantee with require the exact gradients, but computing exact gradients for the loss would require to go through the full set of data with every gradient evaluation that does not scale with the big data, but instead of using statistic gradient descent, where the gradient is computed only with a batch of the D data set with a congruent data fixed size with K, some sample uniformly from who hold D core references in C. And then Atom algorithm, I really don't give a shit even though that's my name. I'm not going to read it. Deep reinforced learning value network advantage network action network experience replay priorities fixed quote target key targets etc. Conclusion: conventional feed forward neural networks are no means magic. They are parameterized function with a fit data with conventional neural networks made to do strong good assumption how information processes the images to be structured. Result are greater related to some of the degree of the human visual representation. A large part of the success of deep learning is on the images learn. Long short-term memory, good assumption, but the memory signal help represent time and theory with the flexibility clicking together the neural set structures. General differential computation graphs is great. All these innovations of the weight-rated testing, formulation, structural models of the machine learning, major strength of the neural nets, or capacity that even the massive parallelized computation that can be trained on tons of data. Maybe they don't even need to be better than the nearest neighbor to look up, then they could be queried much faster. Chapter 12, Explainable Artificial Intelligence. Explainable artificial general concept of explanation, data object with method input, counterfactuals, and Pearl, fitting interoperable models of the black box, sensitive to the analysis in general of the neural nets, influence, function, relevance, propagation, relations, the universal effects, post hoc radicalization, why carries, explainable with the following dossier, the chemical argument, classical engineering, complete objective evaluation, formal guarantee, system activities, well-defined objective trust. Novel AI applications, incomplete, objective ethics, fairness, open bias, privacy, safety, robustness beyond testable for the formalized domains, most object with trade-offs. In those cases, we want interpretable models and predictions. What does the explainable mean? What does explainable mean? Why would you go to university today? In cognitive science, counterfacts for the machine learning decisions has 4 ingredients of data, objective, method, algorithm, hypothesis, space, M, such as function of the method, algorithm, hypothesis, space times to the objective within data. The query input X, or the recall parallels notating over the cause casually based on intervention. Finding interpretable model of black box. Starting in the 80s, the robust reasoning, integrating rule-based, similarity-based reasoning. And then some other books, Interpreting Black Box Models of Model Extraction, 2008. Great work, Casual Generated Neural Networks, Gini and Seabag, sensitive analysis, optimization, consider general problem. With compute the optimum, then explain the optimum, sensitive analysis for the optimization, consider infinitesimalism variation. Sensitivity analysis optimization. Bottom line, we can analyze how to change the optimization problem and translate the changes of the optimum X. Different optimization can be embedded with the auto differentiation, computation, graph, TensorFlow, important implication, differential physics, but not definable across the constraint and activation. Sensitivity analysis for the neural nets. Function for some of the input feature for the discriminative value with the motility at all of the function understanding with the lower level of mechanist algorithm understanding feature for the X are assumed to be some human interpretable domain image of the text and explanation collection. Interpretable features contributed to decision. Sensitive analysis result of the US gradient quantifying contribution features to the value. Guide backup propagation corresponding image crops. Correct backup prop, RELU, correct guided backup prop. Relevance propagation detailer decomposition only grants decomposed value with adaptive additive relevance per feature. Detailer decomposition ReLU networks with piecewise linear easier equivalent propagation first order Taylor coefficient through a network. Function analyze similar type of decomposition. Relevance propagation, deep Taylor decomposition, imminent heap map bike, image heap map person. Relevance propagation, deep Taylor decomposition, image FN with DNN. Feature inversion, define the minimal image of the same value, constrain with the masking of the original image. Influence and function sensitivity of the weight sensitivity of the weighted rate reason testing data set, leaving one over the retraining, waiting with the training point, thereby object with the training point itself with the input the image, using linear sensitivity analysis. Post hoc rationalization. Given an image, a predicted classification learned to rationalize the data includes explanation, catches, Caltech, birds. Plus 5 sequences of each of the name of the bird, of the red feather, the black face, pitch, and then the prepositional logic, motivation outline. Most students who've learned about the prepositional logic first class of the represent the simplest, most kind of the logic with my motivation to teach for the really precursor of the first order of logic, which is covered in the next lecture of the intro of the next lecture of motives of the first order of logic and the detail of the main point of the recent year of the more important development of the unified first order of logic methods. Probabilistic reason learning method will really allow us to tackle the novel problem lecture. We go quickly over the syntax semantics of the prepositional logics, which cover the basic methodologic interference with the forward and backward chaining as well as resolution. Syntax and schematics. Outline example of knowledge-based agent, WOMPAS, word, world, logic in general, models of entailment of proposition, Boolean logic, equivalence, validity sets, probability interference rule for the improving forward chaining, backward chaining, resolution. Knowledge base. Agent maintains the knowledge base. Knowledge base is equal to a set of 7 formal languages, WOMPAS, word, description, performance measures, and environment. Actuators and sensors, explorers of the WOMPAS world. Other type spots. Logic in general is a formal language representing information such that the conclusion can be drawn. Syntax defines sensitivity of the language. Semantics defines the meaning of the sentence, define the truth of the sentence in the world, and language of the arithmetic, and the sentence if it does not, sentence if the truth of the member does not less than the number, the truth of the world where blank, and the false of world where, and that's basically your DOS right here, like what it's called strings. Notice that the general logical language elements are sentences of the models, world stated description allowed to evaluate the truth of the unique any sentence of the well defined of the models for which is the whole of the entailment for goal rung, an equivalency of the KB set with the conjunction of the sentence of the interference perceived that I can infer from the KB, sentence of the I of the KB applied with the KB coherent, when the completeness of the implies KB positional. Prepositional logic, sequence, sentence, automatic sentence, complex sentence, automatic sentence, true, false, PQ or R, complex statement, sentences, sentence greater than, less than, value, sentence, result of the sentence, or reversible sentence. Positional logic, semantics, each model specifically true for each of the prepositional symbol, which of these symbols are possible, the model is enumerated automatically, rules evaluating the truth of the respect of the model. Some proof of the process value with the arbitrary sequence. Notion of prepositional logic and summary conjunction, the disjunction, negotiation, implication by conditional, or the statement, the sequence of logic, or the symbols in the grammar of the prepositional logic, validly true with any of the method of the true, unsatisfiable the true with the no method, unsatisfiable literal A and A negatively with the C and F conjunction, with clauses, horn clause, with the conjunction symbol, the horn form, conjunction with the horn clauses, mud, poems, rules, completing a horns, KBs, the resolution rule, completing with the prepositional logic, C and F, let. Alright, logical equivalency. Two sentences logical equivalent in true same models as A with the only of the A and the B with the N, commutatively, greater than and left associated, greaterly, accusively, graph with the double, the negotiation and elevation, contraposition, implication, elimination by conditional elimination, D. Morgan, distributive of greater or less than, or greater than. Entailment of the Wumpus world situation, and his example. (13.2) In inference methods. In inference, general sense of the meaning to give some of the pieces of the information provided to observe the variable to knowledge, be the implication implied information with the posterior with the other things not observed variable sentences. Sentence can be derived with the KB, perceived with the consequent with the KBD, hashtag with the kneel with the entailment, the kneel with the hashtag with the interference finding, and it was found this with the sound with the KB, with also true with the KBD, with the completeness is complete whenever the KBD is also true with the KB, and then preview with all the defined logic, first order logic, spent with enough to say almost anything interesting that exists in the sound with the complete inference procedure. This is the procedure will answer any question and answer the files from what was known as the KB. Inference and enumeration, depth of the enumeration, all models and sound complete. Proof method divided into roughly two kinds: application and inference rule of legitimate sound generation. New sentence from old proof sequence of the inference rules. Application can use the inference rule of the operator steering search algorithm. Typically require translation sentence with the normal form. Model check with the two-room table of enumerating and always expectational number to improve the background of the data with the Putin logman and low of the hand. C book has static search model searching sound but incomplete. Misconflicts like hill climbing algorithms, forward backing and chaining applied with a KB with a horn form, and the horn form restrict with a KB with the conjunction with a horn clause, with the proposition symbol, the conjunction with the symbol, result, the symbol, minus pinning if the horn form, complete with the horn, is with the AB with the E with the forward chaining and the backward chaining, the algorithm, the very natural run in linear time. Forward chaining of the represent of the KB as graph, finally aim with the rule to precise with the test for the KB, the conclusion, the KB unitarily util query is found. Forward chaining examples. Alright, forward chaining algorithms and proof of the completeness. Forward chaining derived with every atomic sequence within tail with a KB to reach with the forward core. Forward chaining received with a fixed point of the new atomic sequence derived with the shape of the final state of the model with the assignment of the truth false symbol of the every code of the original with the KB to true with the M with the previous clause is false, and the true with the M and B with the false M, and therefore the algorithm and not reach a fixed point with the N method is called model with the KB. The KB is Q with the query is true every model with the KB, including M. Generally construct any model with the KB sound inference check with the alpha. Backward chaining idea with the work backward from query with the proof of the query with the backward chain, check the query of the known already, and proof of the back chaining L almost premises some of the rules, concluding all valid solution. Check with a new sub goal, also with a goal static. Avoid repeated work. Check with a new sub goal has already been proved true, then has already been failed. The backward chaining example, and I don't give a shit. Forward chaining is a data-driven automatic and conspicuous processing, objecting recognition, routine decisions may do lots of work irrelevant to its goal of the backward chaining. The goal of driving the appropriate the problem solver, wherever it is. In many cases, how to get a PhD in programming. Complex back chaining can be much less than the linear side of the KB with the conjunction of the normal form. Conjunction normal form with the dysfunction literal with the cause of the resolution interference of the conjunction normal form complete with a prepositional logic where the complete complementary literals E.g. resolution sounding complete with a propositional logic version of the conjunction of the normal function, eliminate, replace, move it in Morgan rule of double negotiation, applying the distributive laws over the flattening, resolution algorithm, proof of contradiction, show that the kilobytes unsatisfiable. So many local agents apply inference of the knowledge base to derive the new information, make a decision based on context or logic, syntax with a formal structure sense for the schematics, true for the sense of the weighted rate, tell, prominent models, eliminate necessary, true for the one sentence, given another the inferences, given the sentence of the other sentence, the sound of the derivation, produce the entailed sentence for the completeness derivation that can be produced in entailed sequences. Once the world requires the ability to represent partial negotiated information reasoned by case and etc. Forward, backward, chain, linear, time complete. Warring clauses, resolution complete with a propositional logic. Propositional logic lacks excessive power. Alright, 14. First order logic motivation outline. Alright, Introduction to Artificial Intelligence, Mark Toussaint, 14, Chapter 14, First Order Logic, Motivation Outline. Our first order logic is exactly sometimes been thought as good old-fashioned AI, which with the central target of critique AI research coming from the other field of the probabilistic region of the machine learning. A bit oversimplified, but the AI winner makes researchers decide logic doesn't work, therefore AI doesn't work. Instead, the focus should be learning and probabilistic modeling. Some comments on this. First, you should be clearly distinct between logistic reasoning and the inference of the two. The first order of the relation of representation, the logic representing reasoning indeed are only applicable to descriptive and deterministic knowledge bases. As learning knowledge is hardly deterministic, it cannot be based any in view of logic reason that does not apply well. In my view, there's one core problem with the good old-fashioned AI, the fact that logic reason codes not uniformly with learned models. However, first order representation means represent with the knowledge and straight, that refers to only object properties relations, therefore generalized across object identities such as first order logic knowledge based in the first order knowledge representation, but research should advance with the tremendously nowadays with the represented, learned, classified regressions, graphic model, Markov, the decision problem, the first order of the call of the relational and lifted wave of the later core probabilistic formulas account for unitary and learning the central state of the art provides a series of unification probabilistic first order representation. I think it is what makes it important to learn and understand the first order representation, which if it be taught with the context of first order learning, the reason for the inference made, one require the minor relationship probabilistic models. Of course, different classical logical reason, therefore, I think about with the logical reason and learn less important for the knowledge of the logical representation. Some of the basic aspects of the logical reason, such as the computing all basic substitutions of the abstract sentence, thereby grounding the sentence in essential in all first order models. Modern research rational machine learning is around 2011 and let some of the new optimization of modern AI called the Spring AI algorithm, new drawn with artificial intelligence 2011, the wave of the optimism that got overruled new hype deep learning, which media is often equated with the AI, however least of up, no one should clearly distinguish between deep learning as a great tool with machine learning, huge amount of data reasoning, included with the model-based decision-making, control planning, and also Bayesian learning, few data. The lecture introduced to the first order learning, the goals of the first order learning, the basis of the decision problem, the trips, rules of the as well, the relation probabilistic models such as relation reinforcement learning, statistical relation learning method of the briefly introduced in the next lecture, introduced the first order logic basic interference algorithm, perhaps one of the most in concept of the problem of computation substitutions. I'll look at the unification matching problem where much of the computation complex of the first order learning representation arises. First order learning of the language of defined syntax schematics and gives example limitation problem of propositional logistics. Propositional logistics, nice proper the propositional logic declarative of the piece of the syntax correspond to the fact that propositional logic allows partial distinctive disjunction negated to information unlike most of the data structure of the database. Propositional logic representational meaning derived from the meaning of the B1 and B2 meaning propositional logistic context independent unnatural language where the meaning depends on the context. Limitation Propositional logic's very limited expressive power on natural language. We cannot express the cover the previous adjacent squares except for the writing in one each of the square. First order logic. Whereas propositional logic assumes that the world contains facts, and first order logic, like natural language, assumes that the world contains the object that the people have, the number theory for the round McDonald color baseball card for the war century of the relations round bogus prime and the multi-storied brother of the bigger than inside out part of the color occurred after its own comes between functions father best friend thing third inning of the 1-1 war over the end of first line syntax elements, constraints, predicates, variable connectivity, equality, quantifiers, and functions. First order line syntax, grammar, synthetic, atomic sequence, ratio to complex sentence, ratio of flip, variable, and sentence. Atomic sentence, predict, terminal, term is equal to term, function, term, constant, variable, complex sentences, greater than, equal than, and results in a resultant sentence. Universal quantification variables and sentences. Variable sentences is true model of the if true of being each of the possible objects of the model. Essential quantification, true model if the P is true of the beginning of the sum of the possible objects in the model. Probabilities with quantifiers opposite xy is the same as opposite x. So we have distributive and copies is the same, and all the distributive copies, and then it gets into greater than, less than. Quantifier dually can equally be expressed, and then you have square roots and should say squaring the cube. Smacks truth and first order logic. Since they're true, respect for the model with the interpretation model that contains a greater than one object relating to among them. Every interpretation specific reference for common simple objects, predictable and predicated symbols, relation function, symbol functional relations, atomic sync for the predicate, determinant n is true for the object that refers to the term and one and term n. Relation referred to the predicate. Nobody's stupid. Models of first order logic, lots, and entailment of propositional logic can be given in enumerating models. We can also enumerate the first order logic model given by the kilobyte, and each number of the domain numbers of element n of the 1 to the infinity, the predicate of the pk, the vocabulary, each of the possible k, a, r, injury, or any relation to the n object. Constant symbol C for the vocabulary for each of the choice of the relevant C for the n objects, enumerating the first order law of the more infinite. So if you're looking for something with a C in it, you can put an asterisk in your DOS problems. First order learning inference, universal instantation. The KB universally quantified sentence that may be added to the KB instantation sentence where logic variable is placed by the concrete ground term. Existential instantation, KB, essentially quantified sentence, in which may be added a single instantaneous sentence of the KB where the logic variable is replaced with its column, the constant of which must appear with the elsewhere on the knowledge base. Provided C1 is never the new constant symbol, this column constant, and where the new E is the new constant symbol. Instantations continued. UI can be applied several times to add new sentences with the new KB logically equivalent to the old. EI can be applied to replace existing sentences with the new KBI equivalent to the old, but satisfy if the old KB was satisfiable. Prediction to propositional inference. Instantational quantified sentence allows for the grave of the KB is to be made for the KB propositional emphasis of the KB just as the following. Instantational universal sentence all possible we have, and then so you made a batch file of everybody's names with a king and a John in it. New proposition, King and John, Greedy John, Evil John, their theory of the proposition, claim, ground sentence entail with the proposition KBD if entitled with the original first line of kilobyte with every first order learning kilobyte with a preposition preserved entailment. Therefore, first order learning inference can be done prepositional kilobyte query applied with the resolution return result. Problem function symbol there infinitely may be grounded terms father John. Theorem Herbrand and sentence with the A and the tail of the first order line learning kilobyte is the entail of the finite subset with a propositional kilobyte. idea for n for 0 and infinity to do with the creational proposition KB instant with the depth of the n term for the c with the additional n is be the key p. The problem works as entailed loops as a the not attainable theorem. First order logic semi-decidable. Inefficiency not naive propositionalization. Propositional generalization lot irrelevant sentences. Proposition produce not which irrelevant to the query. PK array predicts constants of the P and then instantation function symbol that gets much more worse. Unification instead of instantaneing quantified sentences, all possible ways that we can compute specific substance of the make sense of their substitution, unified abstract sentences such that the rules can be applied. In previous example, the evil rule can be applied when substituted to substitution. So for the king, So generalized modest Pointians, every substitution is 0, such as the opposite A equals 0. The inverse of A equals 0 unifies P to 1, P to I. We can apply blah, blah, blah.